Right, this presentation, data cleaning and spotting outliers with univariate. Statistically speaking, an outlier is an observation that falls outside, it's at the extreme end of the data numerically to the rest of it. I suppose I'm interested in outliers because I see myself as an outlier myself, but more of that as we go on. I'm not a statistician, so these sort of graphs are a bit sort of GCSE, sort of lower grade school. But basically, they're very important to the pharmaceutical industry because, well, we have our inclusion-exclusion criteria. We're trying to recruit a population that we could predict the behavior of and maybe try and improve in terms of efficacy, and also spotting any particular safety defects that they have. Now, generally speaking, we want to see the normal distribution, the actual curve on the left, but if you have the curve on the right, getting feedback from the mic anyway, if we have this curve on the right, then you can see that maybe there might be some outliers, maybe some data problems, data quality errors. No matter the reason for it, then it's good to spot these quite early on so you can do something about it. In fact, just recently FDA produced some guidance in August about risk assessment, risk monitoring, and an exercise such as I'm going to show you would be quite useful in complying with that. ODS. If you do an ODS trace on, you have a standard kind of set of tables that the ODS uses to generate the output from PROC Univariate. The ones that you probably might be interested in terms of outliers would be the extreme obs table that produces something like this, with the option next are obs, that you can control how many extreme observations you see on your univariate output. For me, that's not enough, because I want to actually know that only catches 10 observations. I want to find all the observations that are outliers. So it's a good one to look at the quantiles part of univariate. Now here I've marked with an arrow what defines the outliers in this case. If you think back to that F-shaped curve, there you can see just by eyeballing the figures there that the distance, numerical distance between 99 and 100 is much larger than, for instance, the numerical distance between all these other quantiles, or percentiles, I should say. So likewise, between 0 and 1, and also 99 and 100 in the other example there. So I was doing this, I was running univariate and then eyeballing the data like that, and I thought, this is something a computer should be able to do. I should be able to do this more intelligently, rather than just looking at pages and pages of output to see what jumped out at me. So programmatically, I wanted to define what I was doing. So I came across, I don't know how statistically accurate this is, but I decided upon a plan to look at the 5th and the 95th percentile, and then project backwards from 5 back to 0 to get what I expect to be the extreme observation, the expected minimum value at one end, and also from 95 through to 100 what the maximum value would be at the other end. And anything that fell outside that I would determine to be an outlier, or perhaps some dodgy data. Labs might be a good example to look at as well, because you have some conversions things, maybe the conversion's gone wrong. Or genuinely, these might be genuine outliers, might be sick patients. All depends on your population that you're actually analyzing. So here's a little bit of code. Got PCTL, PTS, percentile points. That's 5 and 95 equally. You could do P5 equals P5, or P95 equals, name whatever variable you want to call it. You've got your min and your max. And then from the output from that univariate, I'm basically taking that 1% slice, multiply it by 5, based on the 95th and the 90th, 95th and the 5th value, dividing by 90, getting that 1%, and then back projecting and forward projecting. There's a max and a min going on, so if I've back projected or forward projected too much, then it's actually taking the genuine value of the min and the max, rather than my exaggerated min and max that I've done based on our percentile thing. There's the data set that I'd get from that, and there's the code that you can compare with. First column is what the max would produce. There's the min. There's our 5th percentile, 95th percentile. And then these are my projected P0s and P100s, and the 1% bit there. And finally, once I've got all that, then I get my original data and merge it on, selecting only those observations that fall between my projected P0 and my minimum value, and also at the other end, my projected 100 and my maximum value. So I get a data set out of that, and I send it off to data management to hopefully get a bunch of queries back and clean the data. That's it. If you want to read more about this, if you feel that you need to, then there's a good section on univariate and Cody's data cleaning techniques, and of course the procedures guide.